In this video we will prepare oxalic acid using an old-fashioned preparation which uses nitric acid to oxidize cane sugar. We're just using regular granulated cane sugar, which is near enough pure sucrose. Weigh out 10 grams of sugar. Transfer this into a large 250 ml conical flask. Now measure out 50 ml of concentrated 68% nitric acid. Transfer this into the flask containing the sugar. If you use a beaker for the reaction, be warned that the mixture will bubble and spit and may cover the area in acid spray. Give the flask a swirl for a few minutes and you'll see all the sugar dissolve in the solution. But there's no reaction yet. Place the flask on a hot plate and very gently warm it. You're aiming for a temperature of about 70 degrees C. At about 40 to 50 degrees you'll see a yellow color and some brown nitrogen dioxide gas produced. The mixture gradually gets darker and suddenly you'll see a few bubbles in the mixture. This is the reaction starting up. Get your strong ventilation switched on. Within seconds the mixture starts to react vigorously and a lot of nitrogen dioxide is produced. This is extremely toxic, so take care and use strong ventilation. The reaction is strong but doesn't get out of control, as you can see. Once the reaction starts, switch off the hot plate as the heat generated will sustain the reaction. After about 10 minutes the reaction dies down a bit. At this point switch the hot plate back on again and keep the mixture boiling and slowly evaporating. Nitrogen dioxide continues to be evolved, and keep the evaporation going until you are down to about 30 ml of liquid. At this point transfer the hot liquid into a beaker for faster evaporation. Now return to the hot plate and evaporate down by half until around 15 ml remain. Some nitrogen dioxide continues to be evolved during this period, as you can see. Once you reach this point measure out 15 ml of water. Add this to the boiling acid mixture. And now reduce the mixture down again on the hot plate. A small amount of nitrogen dioxide will be formed now, but not much. The target is to get down to about 10 ml of liquid remaining. This is about right. Once you're there, allow to cool slowly. You'll quickly see crystals forming. And after chilling for a while you'll end up with a slush of crystals in the beaker. Transfer into a filter. We've used a glass sinter for this, but you could use a filtered paper just as well. You'll need to filter for a while in order to get all the liquid off the crystal. Then allow the crystal to dry thoroughly on the filter. Here's the product. 4.8 grams of oxalic acid dihydrate. If sucrose can potentially yield to molecules of oxalic acid due to it being comprised of glucose and sucrose, then this is a 65% yield. You can purify this further by recrystallizing from hot water. You can also dehydrate in an oven at 120 degrees to give the anhydrous acid. Stay tuned for more videos.